So now we're looking at changing the subject of the linear formula. So the subject just means that it's the variable that's all by itself on one side of the equal sign. So I gave you a couple of examples. So for y equals mx plus b or plus c, y would be the subject because it's the one that's all by itself. For area equals length times width, area would be the subject because it's all by itself. So for example number 1, we're making x the subject for this equation. So that means that we need to get x all by itself because right now the subject is a. A is the one that's by itself. So we're just going to start rearranging our equation to get x all alone. So we're going to multiply both sides by 2 and then divide both sides by y. And that's it. Example number 2. Right now the subject is I because that's the thing that's all by itself. We want to make n the subject, so we need to get that p and that r out of there. So we can divide both sides by p and then divide both sides by r. And that is it. Question number 3, we want to make u the subject for this equation. So right now the subject is r because r is the thing that's all alone. So we need to start moving things out of that right-hand side and onto the left-hand side to get u by itself. So we subtract at from both sides. We find that u equals r minus at. And that's all you have to do for that one. So this is the formula that's used to convert degrees Celsius to degrees Fahrenheit. So you would put in whatever the degrees in Celsius is for C, and it pops out the degrees in Fahrenheit. So part A was 28 degrees Celsius to degrees Fahrenheit. So we're trying to find degrees Fahrenheit, which is the way that our equation is already set up. It's set up so that we just sub in degrees Celsius and it pops out Fahrenheit. So that's all that we have to do. We take the equation exactly as it is, plug in 28 for our C, and when you plug that into your calculator, you'll find that in degrees Fahrenheit, it's 82.4. So now working the other way, so we're being given 72 degrees Fahrenheit, but we're trying to find degrees in Celsius. So we're trying to find C, which means that C would be the subject of our formula, so we need to rearrange. So we're going to move that 32 over, so we subtract 32 from both sides, and then we can multiply each side by 5 over 9. So I just flipped this fraction upside down. So this is the equation to find degrees in Celsius. And now all I have to do is plug in what they gave me. So 72 degrees Fahrenheit goes in there. Plug it into your calculator and you should get that the degrees in Celsius would be 22.2. So this is the formula to calculate the area of a trapezium. So they give us our two side lengths, our two parallel sides, so that's A and B, and it has an area of 50. And we're trying to find the height of the trapezium. That's our h. So h is going to be the subject of our formula. So I'm going to move that 2 out of there, multiplying both sides by 2. And then since I'm multiplying h by this a plus b bracket, I can divide each side by that bracket. So this is the formula to find the height of the trapezium. And now all I do is plug in what I know. So the area was 50, A was 8, B was 12. Plug that into your calculator to find that h equals 5 centimeters.